Please welcome Jude Cadet, Platform Architect and System Engineer at Fiserv.
Hi, everybody. Super excited to be here. This is my second time speaking for Redis, and just want to kind of go over how I work for Fiserv. I am a systems engineer over there, and I'd like to share my experiences about what we've done with utilizing CRDTs and creating CRDBs from a platform perspective. Just going to kind of go over a few things on who we are as Fiserv and talk about how we utilize CRDBs and kind of go over some things at the end. So first of all, who is Fiserv? Fiserv is a global leader in the financial services since 1984. We specialize in payment processing, risk compliance, customer and channel management, and financial insights and optimization. On the back end, there's some things that we are more familiar with being known for. One of them in particular is Pop Money. That's us on the back end. We are on the back end for Zelle. We just provide that service for banks, and they just kind of label it and use it as their own. We currently have approximately 12,000 clients in more than 80 different countries using all of our products. And we are a Fortune 500 company. We have been for the past 8 years. Currently, we have about 24,000 employees, and our revenue is $5.82 billion for last year. Now, the number for our amount of employees it's going to relatively change because I'm not sure if you guys have heard that we have acquired First Data. So that's going to change our number of employees as well as clients as well. So that's going to definitely increase our footprint about how we use Redis as well as other products. If you'd like to get more information on Fiserv and just about it as a company, you've got a couple of links here. You can go to fiserv.com/about. And if you'd like to know about our Fortune 500 standing, feel free to go to Fortune's site. Now, one of the things about Redis is how it works for us at Fiserv. It initially started with us being interested in creating a cloud infrastructure, a private cloud infrastructure for our applications so that we could start deploying applications in the cloud and do cloud offerings. And one of the things that we had reached out to Pivotal Cloud Foundry, and they strongly recommended that we used Redis on the back end for that, which was one of the reasons why we decided to go ahead and go into using Redis. And as we started using it, we realized that it has a couple of other use cases that we can use it for. So we started using it for a primary database for some of our applications. We've used the open source version, but the open source version just doesn't have enough tools or redundancy for an enterprise environment such as ours. So we decided to go more so with the Redis Enterprise version, and it has been extremely helpful with everything that it offers. We were using Coherence as our primary caching layer on the back end, and we decided to kind of move away from that, and right now Redis is our primary choice as far as when it comes to using anything for a caching layer. We're using it for session state. The current state right now is just mostly for user tokens, for user login tokens, and user information. And the future state is we're going to continue using it as a caching layer, but we're going to start using it much more as a primary database. We're also looking at seeing what we can do as far as growing it because we are experimenting with using IBM Power. We're looking at seeing how that's going to work out. We ended up getting a big deal with IBM, so we've got a lot of hardware and not so much of a use for it. So So we started with running RHEL on IBM Power, and we're kind of going from there, and now we're actually testing, seeing how we can implement running RHEL on that IBM on Power and seeing how that goes. And the one thing that was great was Redis has been fully supportive in deciding to help us explore that option. Let's see. Now, currently, we're going to go more into the CRDBs and CRDTs. One of the reasons why we decided to go with CRDBs is because we realized that we needed a better disaster recovery structure with our Redis infrastructure. We started from using Redis 4.3, and as Redis continued to grow, we decided to kind of move along with them and test the newer versions. Once they got the 5.0 in it, and they explained that the presence of CRDBs and having an active state with Redis databases was into play, we decided to go ahead and decide to use that for our disaster recovery infrastructure. One of the things that kind of helps with that is that what we were doing before is we were using replica of, which involves taking an entire copy of a database and copying of a Redis database and copying it over to another Redis cluster instance. And it's kind of cumbersome, especially to have to do that all the time. I know network latency can kind of play a big effect with dealing with replica of. And not only that, the failback over process would be much more cumbersome because we would have to return copying that entire database back to the primary database once we get everything restored. Going with CRDBs, it gave us the option of actually just keeping everything in an active state. There's automatic syncing between the databases that are on the two different Redis Enterprise clusters, and we don't have to worry about failing over. All the changes all the changes that are made on either side will be synced up and will reflect, on both sides. So that's one of the reasons why we decided to go with CRDBs. That way we don't have to worry about the manual syncing. Some of the requirements that came along with using CRDBs, just using Redis Enterprise altogether is you definitely have to have a good network connection across the WAN. You have to use DNS just because DNS is a big portion of Redis Enterprise. That's just how the cluster works and cluster failover works. It's using DNS. And of course, the hardware. The hardware, you can either use bare metal, but we're mostly using VMs. We're a big VMware shop, so we're kind of using just VMs and the resources that VMware is providing for our Redis clusters. As far as some of the challenges that we came across with deploying CRDBs, it's just some of the network connections. Sometimes we had to make sure that everything was there. We had to make sure all of the one of the things about Fiserv is that Fiserv is very secure, and not every port is open. So going through trying to open up all of the required ports that are needed can kind of be an act of God sometimes, in which it's an uphill battle, but we finally got through it and got it done. And another thing is there's very limited monitoring on the Redis side, on the enterprise side for the databases themselves. I think there's some email notifications and very small other things. So what we have done is we were able to utilize the API, and we were able to use Splunk to go ahead and pull, access the Redis Enterprise API and be able to pull information that way. If there's any changes or anything that would happen, Splunk would go ahead and report it. So I'm going to go a little bit over about how we've set it up in a disaster recovery aspect at Fiserv. And like I said, I'm mostly going to just cover the platform perspective. I'm not going to get down into the data types exactly. I'm just going to really show you how we've been able to lay everything out. So here's an example. So we actually have 3 major data centers currently at Fiserv. Right now, initially starting out, we're starting out with setting up with the 2. So we have application instance A, which is connecting to our data center that's over in Georgia, and all the CRDB magic happens between those two enterprise clusters, which are sitting in their respective states, and then we've got another data center over in Texas, which also goes over to application B. So as any changes may happen on the app, and they're both always up, it's always going to be active. Any changes happen in application instance A, it will automatically sync those changes, any writes that occur in that application A does to the Redis instance in Georgia, it will automatically sync to the Redis instance in Texas, and application B will be able to access that information and vice versa. So. And this is just a few steps on actually creating the CRDB if you were ever interested. Like I mentioned earlier, you definitely have to use Redis Enterprise, and Redis Enterprise has this pretty little GUI that you can use if you're into pretty pictures. So you've got once you log into the UI, you'll see you can go to the menu and you will see a Create New Database icon there. So when you get to there, all you have to do is click on deployment, and you'll see Geo-Distributed. You have to make sure you select that, and that will create the CRDB, which is a conflict-free resolution database, which is what utilizes the data types. And if you look over here, you'll see where you can create the database name. The protocol runs on is automatically given to you, unless you're actually using Redis on Flash, which is a whole different story. You can dictate how much memory is allocated over to it. And if you enable replication, what that does is that actually gives you another a copy of the database on the current cluster that you have on another node. So one thing you have to keep mind of is when you're creating a CRDB, what differs from that and from a regular database is that if you create a replicated database on a regular cluster, non-CRDB, that's going to create another copy, and that's going to use up one of your shard licenses. So therefore, you have to pay attention to how much licenses you are utilizing or that you're paying for with that Redis cluster. In the case of CRDBs, because it's going to create a copy of the database on the secondary cluster that you add to it, you're going to end up utilizing 4. You're going to end up utilizing 2 shards on the current database, on the current cluster, which in this case we could say if I created this in the Georgia database, in the Georgia region Redis cluster, it will be using 2 there, and it would create another instance in the Texas data center cluster, and it will create 2 more. So altogether, the CRDB alone will use 4 shards. So you have to pay attention to your licensing and make sure that you keep in mind that if you're going to add replication, you have to have at least 4 shards allocated, and that's 2 per cluster in each data center that you're going to use it for. Data persistence, what it really does is just it creates a copy of the database. It just dumps it to disk, and what you can do is you can either do it by snapshot, where it does an entire snapshot of all the data in that particular database and dump it to disk, or you can set it to actually write it at specific time intervals. Now, if you go down further to the participating clusters, you have to make sure that you have the 2 clusters from the 2 data centers that you're looking at to implement the CRDBs. You have to use a login, and you have to make sure that it is a login with admin rights to the cluster, because once you use that login, once you add that login to the CRDB creation, it will use that same login to perform every sync that it needs to. So you have to make sure that it's an admin user that you're using, and you'd have to create that admin user on each particular cluster. I almost forgot here. And you could also add SSL a communication if you want to have the application communicate using SSL for data in transit. You also have the option of creating it by command line, and that's if you're interested in scripting it or automating it, you can use the CRDB CLI command via command line and just use CRDB create. The options that are required are you need the name of the database, the memory size. Unlike creating a normal database that's non-CRDB, it will randomly create a port, and when you're using CRDBs, you have to declare a port number. Anything within the recommended port range, I think it's from 10,000 to 19,999 that you have to use for CRDB. So you have to make sure that that port range is opened between both the clusters, and that all the nodes in the cluster can communicate across that port, because once you create the CRDB, it's not going to really tell you, it's not going to allow you to place the database where you want it to run. It's going to automatically pick which node it's going to run from. You can always change that later. You could always move the database shards to another node if you want, but it's probably best just to make sure that all the nodes on both sides have those ports open, so that they can communicate with each other. You can declare the shard count that you want to use, and then you have to use the fully qualified domain name for the instance. And that's, as you see below the example, it shows you using CRDB create. And if you look a little further down, the instance FQTN would be the whole DNS name that is given by the cluster. So once we had the CRDBs up and running, and they were using the data types, everything looked good. Just to kind of show you exactly how the flow of data went, there is a process that will be on the cluster for each particular CRDB called a syncer, and the syncer is a watchdog process. And I'm going to go a little bit more into it a little bit later, or the slide after. And it actually just monitors every change that occurs to the database on each side. So when it comes to writing data, application A will write the data to cluster 1 on that CRDB endpoint, because every database that's created gets an endpoint. And then from that endpoint, it will go from the endpoint to the syncer. The syncer will be notified, and then the syncer will go ahead and authorize the write on cluster 2's CRDB endpoint. And same way with the other way around from application B. It's going from cluster 2 CRDB endpoint to the syncer to cluster 1. So if you want to know a little bit more about the syncer itself, like I said, it's a processor that monitors the changes on each CRDB. It runs on one cluster, establishes a connection to an endpoint on the other cluster. And if you ever want to verify that it's running, and I'm assuming everybody's running this on Linux, so you can just do a netstat-anp, and you can grep for syncer, and that will show you that the syncer's running. And as you can see, it's got the IP addresses of both clusters, including the port that it's communicating across on both clusters, so that you can see that it's actually not only running, but it's actually connected via TCP on both clusters. So, and that's pretty much how we've used it at Redis. Everything is, I'm definitely interested in how we're working with Redis. Redis has been working with us. We're definitely going forward with a lot of good stuff. If you have any questions, you can feel free to hit me. I'll be around today, so feel free to catch me in the hall. You could also catch me on Twitter. And if you want more information about CRDBs and CRDTs, you can go to redislabs.com/?s equals CRDT.